In this second presentation of the playlist, we will look into the topic of two-segment coding style. After watching this presentation, you should be able to write VHDL descriptions using this code style. Now, if we look at the standard representation for a synchronous sequential circuit, as shown in the top right for the basic D-type flip-flop, and also here in the center for the case of the general representation of a finite state machine, you will see that the information related to the state comprises two main components. The outputs of the memory elements, which are normally referred to as underscore register signals, and their inputs, which are normally represented by the underscore next signals. Moreover, and to improve clarity in the VHDL descriptions and also to simplify the logic optimization during the synthesis process, it is recommendable to create two segments in the architecture body, one to describe the registers and the other one to describe the combinational logic blocks. The combinational logic blocks generate the next state values, as you see here, and also the external outputs. This design style separating the register section and the combinational blocks section is what is called the two-segment coding, and we will follow this style in our course. So if we consider the simple case of a D-type flip-flop, the architecture body can be written using a two-segment coding style as shown here, where I have used it to slightly different colors to highlight the register section and the combinational blocks section. The first segment contains a process which describes the 1-bit register, and the second segment describes the combinational blocks, which in this case consist only of the next state section and the outputs section. Now, as an additional example and slightly more complex, to illustrate the two-segment coding style, we can look at the case of a simple shift-right shift register. So this type of circuits will shift their content to the right by one position for each clock signal. Please notice that the state register section, which is highlighted here, will be the same for every type of regular sequential circuits, because what we are doing here is independent of the type of logic function carried out by our circuit. In fact, what we are describing here is a structure that if the reset input is active, then all register outputs will be set to 0. And otherwise, whenever there is a rising edge in the system clock, the register outputs will be updated to acquire the value of their next state. And this will be the same for every type of regular sequential circuit, be it a counter, a shift register, or other types of circuits. Now, in the case of what makes the difference indeed is the combinational block section, where you see that in this case the next state function defined for the combinational logic section is indeed specific for this type of circuit, which is a shift register. So in this case the most significant bit will acquire the external inputs, and all the other bits will take the value of the bit that was to their left. And of course the least significant bit will be discarded. And the output section simply, in this case there's a single output which is S underscore out, and it simply takes the value of the least significant bit. So before closing, I leave you with one question, which is how would you modify this description if you wanted to have a bidirectional shift register instead of a shift right only register. Thanks for your attention.